All right. You're welcome to our today's class. We are still on the course BDT 253 in preparation for your Npce, for your certification examination as pharmaceutical technicians. So we'll continue from where we stopped yesterday. Can you see my screen? Hello, can you see my screen? Okay. Can you see my screen? Hello? Seems there's network issue or something. Okay. Okay, you're welcome, Victoria. Can you see my screen?
Yes, sir. Good evening, sir.
All right. Hope you can see the board clearly. Can you see the
Yes,
board
sir.
clearly?
Yes, sir.
Well, what data on the board now?
Is it the question?
Can you see? Can you see what? Can you see what I wrote on the board now?
No, sir.
You cannot see what I wrote on the board.
What I'm seeing is, I think it's the shared screen. The question 10 and 11.
No, on the board, not screen. On the board, not screen.
I'm not seeing the board.
Chinaya, can you see the board, not the screen? Can you see the board? Chinaya has left. All right, so let's continue. Okay, today we'll continue from question 10. That's where we'll start from. Okay, read the question.
From the following formula of gastric lavage prior to colonoscopy, calculate the quantity of sodium bicarbonate needed to prepare 100 liters of the formula. Then we have polyethylene glycol 3350 60 ml, sodium chloride 1.4 gram, potassium chloride 0.745 gram, sodium bicarbonate 1.68 gram, sodium sulfate 5.68 gram, water QS 4 litre.
Read the options.
A 44 gram, B 43 gram, C 42 gram, D 45 gram.
All right, but can you see the board now clearly?
I'm not seeing any board.
Are you serious? Adana, you're welcome. Hello? Adana, please unmute your mic. Can you see the board?
Yes, sir.
Can you see the board?
I can see the board, BDT 253.
Victoria, what's going on? Check your the device well. Okay, so let's solve this question. Let's solve the question. Okay, the question, as you can see, the question has polyethylene glycol 3350, 60 ml, sodium bichloride. The question, they want us to calculate the quantity of sodium bicarbonate that is required to prepare 100 liters. This question is from reduction and enlargement of formulas. This question is from reduction and enlargement of formula, is a topic in pharmaceutical calculation. So they want us to, from this question now, this question, the formula, the volume of what you want to produce in the formula is 4 liters. But they are asking us the quantity of sodium bicarbonate that is needed to produce 100 liters. Are we supposed to reduce this formula or enlarge the formula?
Reduce.
Check well.
Are you talking about reducing the liters?
Check well, look at the formula. The formula itself, the amount of products the formula will produce is 4 liters. Because this water, sufficient quantity to 4 liters, meaning that the amount of the product is 4 liters. But we were asked the quantity of sodium bicarbonate needed to prepare 100 liters.
Okay.
So if we have 100 liters,
Sorry, it was a mistake.
You said what?
I said sorry, it was a mistake.
So are we supposed to reduce or enlarge?
We are going to enlarge it.
God bless you. We are going to enlarge the formula. Please be careful. This is an OBJ question. It's an MCQ, and time is a primary. Remember that you have less than 1 minute to answer a question. You have approximately 0.6 minutes per question. So for you to be able to achieve this, be very fast and accurate, and at the same time, cut off unnecessary long steps. Please don't go and start looking for getting the amount of each of these ingredients you need to produce 100 liters. Focus on the one you were asked. You were asked the quantity of one of the ingredients, which is sodium bicarbonate. So focus on that sodium bicarbonate. Am I communicating? Focus on the sodium bicarbonate. So you pick the quantity of sodium bicarbonate needed to produce 4 liters as stated in the formula. You now enlarge it to get the amount needed to produce 100 liters. Is that clear?
Yes, sir.
It's a simple question to answer. Go straight to the point. If you like, since you are enlarging, if you like, you can simply get the enlargement factor. Once you get the enlargement factor, you multiply the quantity of the bicarbonate needed to produce 4 liters by that enlargement factor. You get the quantity you need to produce 100 liters. If you like, you can just do it proportionally. Do it by ratio and proportion. Anyone you use is okay. Is that clear? But I prefer finding the enlargement factor straight up. And how can you find the enlargement factor? Please let me admit some people. Some people want me to I just come in and let me admit them, please. They are refused to be admitted. They're wasting our time. Now, let's continue. So, now, you are producing what you have in your formula, given formula. The amount there is what? 4 liters. But the master formula, which is the formula you want to use for the production, master formula, the quantity there is 100 liters. So if you want to get your enlargement factor, simply divide 100 liters by 4 liters. So use the amount in the master formula divided by the amount in the given formula. Dependence. The formula can be formula from the reference book. Anyone, just divide the master formula, the formula you want to use for the production, the quantity of the formula you want to use for the production, by the quantity in the given formula. You simply do 100 liter over what? 4 liter. And that will give you 25. Liter will cancel liter. This factor, enlargement factor, have no units. This will give it 25. So if you want to calculate the amount of the sodium bicarbonate needed, simply amount of sodium bicarbonate. Amount of sodium bicarbonate needed to produce 100 liters is simply the amount needed to produce this 4 liter, which is 1.68 gram, times the enlargement factor, which is 25. What's the answer?
42.
42. So the answer is C. Very simple question. If you like, you can also set up a proportion. Just do, if 1.68 gram is required to produce 4 liter, X is required to produce 100 liters. You cross multiply, you will still get the same thing. Is that clear? Any question here? This question is from
No,
enlargement. Any question here? This is clear, right?
Yes, sir.
Good. Now, let's go to the next question. I read. Question 11, read.
Low dose aspirin contains one. Is it one? Okay, 1.1 over 4 is what? Pardon, sir.
1/4.
I want to put it in decimal points. Let me leave it like that. One whole
Continue.
number 1 over 4 grains of aspirin in each tablet. How many tablets can be prepared from one avido?
Avido.
I cannot pronounce it. Avido pounds of aspirin. A, 5,600 tablets. B, 4,600 tablets. C, 3,600 tablets. And D, 2,600 tablets.
What's the answer?
I have not solved it. I want to solve it.
Okay. I give you 30 seconds to do that. Joseph, how are you? Martina, how are you? Mama?
Good evening.
Nanya, Kevin?
I need to apply.
So 5,600 tablets.
Huh?
5,600 tablets.
How did they get 5,000? Explain.
They told us from one I cannot pronounce that stuff.
Avido.
One Avadepo, and what was given to us here is 1.1 whole number 1.5 grains. So I converted this one Avadepo pound to grains first, and one
Okay.
Avadepo pound grains is 7,000 grains. So if
Okay.
one half the depot is equal to 7,000 grain, 1/4. If you change it to decimal point, is 1.25. So when you
Okay.
cross multiply, it will give you 5,600 grains.
5,600 grain. Correct. Correct. Because you are asked how many tablets can prepare 1/2 a day pour. How many tablets can prepare 1/2 a day pour pounds? And 1/2 a day pour pounds is 7,000 grain. 1/2 a day per pound is what? 7,000 watts grains. Good. So if 1/2 a day per pound is 7,000 grains, and this what is it called? This 1/4 grains, if you put it here, which is simply 1.25. So don't mind my marker. 1/4 grains is here. So what is the implication? This now, if you convert this now, you can get it in what? In what? Pounds, right? Pounds. Now, but one tablet is 1/4 grains. Let me do it well. Is there anybody here that didn't understand what she said? Let me break it down properly. Now look up. Look up. The question says low dose aspirin contains 1/4 grains of aspirin in each tablet. So one tablet inside of one tablet, we have 1/4 grains of aspirin per tablet. So what we need to find out is how many grains, if 1/4 grains is in each tablet, we now find out how many grains are in 1/2 a day per pound. So if we're able to find how many grains are in 1/2 a day per pound, which is 7,000 grains, and 1/4 grains is in one tablet. But they ask us how many half a day per pound, how many tablets can be produced from 1/2 a day per pound, from 1/2 a day per pound. How many tablets, which is X. But here is in 1/2 a day per pound. We have to move this 1/2 a day per pound to grain. And 1/2 a day per pound here is 7,000 grains. So go straight. Remember, this is MCQ. Don't waste time. Go straight and replace it with what? 7,000 grains. Straight up. Don't waste time. Don't waste your time trying to do long conversion. Just go straight and put 7,000 there. And if you're able to achieve that, you make SD subject to the formula. And this becomes 7,000 grain times 1 tablet. 7,000 grain times 1 tablet. All over 1/4. Of course, 1/4 is certain as saying 4 times 1 is 4, that plus 1 is 5/4. Divide by what? 5/4. Remember your rule of fraction. This will come up. This become 7,000 grains times 4 over what? 5. Simple. Multiply this by 4 and divide by 5. If you feel like you can divide this by 5 straight up. 5 divided 70 is 14. 0, 0. 1,400 times 4. You get your answer. Straight up. 4 times 0 is 0. 4 times 0 is 0. 4 times 4 is 16. Put 6 and put here. 4 times 1 is 4 plus 1, 5. It's 5,600 tablets. Because grain here will cancel grain. You have your what? Tablet. So she's correct. She's correct. Thank you very much, Ada. Thank you very much. Is there anybody that didn't understand what I did here? Who did not understand what I did here? Please ask. Raise your hand or just unmute your mic and talk if you don't understand what I did here. So if you keep quiet, it means that it's clear. So let's move to the next question. No time. Question 12. Please read question 12.
Sodium chloride is a 2-ion electrolyte. dissociating 90% in a certain concentration. Calculate the freezing point of a molar solution of sodium chloride. A 3.53 degrees Celsius, B minus 3.53 degrees Celsius, C 1.73 degrees Celsius, and D minus 1.73 degrees Celsius.
What's the answer? Who can solve this question? This question is from isotonic solution. The question is from isotonic solution. You go down to the dissociation factor or I factor. I factor, then freezing point depression. Freezing point towards depression. Now, for us to solve this question, there are some things you need to understand. What an isotonic solution is. In your biology, you did isotonic solution, hypertonic solution, and hypotonic solution. Can you remember in your biology?
Sir, yes, sir.
Good. Here we say that in hypertonic, the hypertonic solution is more concentrated than the concentration inside the cell, right? So if you put a cell in an environment or a solution that is more concentrated than what you have in the cell, there will be osmosis, right? Exosmosis, right? Water fluid will move from the cell down outside the cell, and the cell will start having issues. True of us. Then when you have put in hypotonic, that is the system you put it, the system you put it, the solution you put the cell, the one that is outside has lower concentration than inside the cell, and fluids, basically water, will move from outside into the cell. True or false? Can you remember all those biology definitions, right? Now, but if you put it in isotonic, everything will be normal. The cell will thrive properly in isotonic solution. Now, in preparation of some medicine that we use in some areas of our body, even intravenous fluids, the one we put in the eyes, in the nose, and some other that have a contact with the body fluid and cells in the body, that particular preparation must be isotonic. Because if it is not isotonic, there will be trouble. There will be a problem. If the eye drop we are using is not isotonic with the fluid, lacrimal fluid, there will be a problem. What it means is that the cells of the eyes will start dying. But you may not know, because the eye is an organ made up of different tissues that make up of different cells. You may not feel it, but the cells are gradually dying. If the eye drop you are using is hypertonic, it's not isotonic, there will be a problem. So as they are preparing parenteral preparation and the one they instill, they take care of make sure that it's pyrogen free, ensure that it is sterile, and also ensure that it's what? Isotonic. Now, having that at the back of our mind, let us look at what is this isotonic. If you don't understand what tonicity is, you will not be able to understand what an isotonic solution is. What is tonicity? Let me assume that you get a solvent like water. If you get solvent is just dead. The water is just dead. The moment you add something like sugar or salt inside that water, that sugar or salt is a solute. As you're adding the solute inside that water, the water will start becoming tonic. You're adding tonicity in that water. As you add that salt, it has become a solution. It's no longer the solvent you know. It has gained some level of tonicity. The concentration has increased. You've added something inside it. It's now a solution. It has become tonic. We are giving it a tone, not just ordinary solvents. And most of the preparation we use in our system are solutions, the liquid ones. So they have tonicity that must be adjusted to be in line with the tonicity of the body fluid to avoid problem. Now, as you are adding this, there's an area of chemistry we call physical chemistry that explains this more. There are different properties of solution. There are different properties of solution we consider. Things like freezing point. You know that water in question, water has a freezing point, and water has a what? Freezing what? Point. And if you add, from knowledge of chemistry, once you add something inside water, the freezing point of that water, the boiling point of the water will increase, and the freezing point will decrease. We call it freezing point depression. Once it gains tonicity, the freezing point will depress. Normally, water freezes at 0 degrees Celsius. But once there's something inside that water, once it is a solution, the freezing point will not be 0 again. It will be depressed to minus something. It will be depressed to minus something. Now, not different solutes. There are some solutes that are electrolytes, and there are some solutes that are not what? Electrolytes. Now, if you add a solute that is electrolyte inside a solvent like water, the concentration will increase. Number of particles will increase because of what is called dissociation. It's also like sodium chloride. If you add it inside water to form sodium chloride solution, sodium chloride dissociates rapidly. In fact, it dissociates even up to 90%, 80% in water. Now, because of this dissociation, number of particles inside that solution will be higher than what it used to be. But if you get something like boric acid is not an electrolyte. If you dissolve it in water, there will be no dissociation. The particles there, no dissociation, just almost the same thing. This will lead us to what is called I factor, or dissociation constant, or I factor, or simply dissociation factor. Now, if you know your formula, something like sodium chloride, normal in solution, it appears like this. If you dissolve it in water, it will dissociate to form what? Sodium chloride and what? Sodium ion and fluoride what? Ion. It will form sodium ion and what? Chloride what? Ion. Please let me address some people. It will form sodium ion and what? Chloride what? Ion. This is solution. You have dissolved this in solution. This is what it will yield. Now, this sodium chloride now in the solution, before it dissociated into this, everything here is intact, 100%. But once it dissociates, from the question, it says it dissociates 90% dissociation. So 90% dissociated. The remaining is what? 10%. 90% dissociated. Here is 90%. It will yield 90% sodium ion, 90% chloride what? Ion. It will yield 90% sodium ion and 90% chloride what? Ion. These are the particles. This thing here now are the particles. It yielded because of this dissociation. Initially, when it was intact, it was 100% undissociated. But the question said it dissociated 90%. So if 90%, this one is the one that particles that are still here, is dissociated into 90 sodium ion, 90 chloride ion. The total number of particles here is 90 plus 90, which is 180. Plus 10, which is 190%. But initially it was 100%. I mean, I see that the particles has increased because of dissociation. Had it been, it was a boric acid. Boric acid will not dissociate 100%, 9%. It will remain 100%. But because sodium chloride dissociated 90%, 90% from this one is here, sodium ion and chloride ion, 10 is still here. Total particle inside this solution is 10%, 90%, 90%, which is 190%. Now, what is this I factor? I factor or dissociation constant for an electrolyte like sodium chloride that dissociate 90%. I factor is the total number, I factor, it's the total number of dissociated particles. Sorry, total number of particles in the system. Particles in the system after dissociation divided by the one that was there before dissociation. So the percentage that was there after dissociation is 190%. The one there before is intact, 100%. So I factor for this sodium chloride that dissociated 90% is 190 divided by 100, which is 1.9. The dissociation factor of this sodium chloride in this solution is 1.9. Had it been it was boric acid will give you 1 because no dissociation, 100. So everything is no dissociation at all. Everything is here is still 100. So at the end, everything is still 100. At the end, before 100%, after 100, no increase. 100 over 100 will give you 1. I factor for boric acid will give you 1 because it's a non-electrolyte. But I factor for sodium chloride, which is an electrolyte that dissociate, according to this question, dissociate 90%. Had it been they say it dissociated 80%, it would have been 20 remaining here, 80 here, 80 here. 80 plus 80, 160 plus 20, 180, it will be 1.8. But they say 90%. So the I factor for this sodium chloride, for this the electrolyte is 1.9. Before you can answer this question, you must get this I factor. What I explained about I factor, is it clear?
Yes,
I
sir.
don't understand, sir. I don't understand, sir.
What the specific, what you don't understand in what I say, the specific.
I came late, so I'm lost. I'm totally lost, sir.
Totally.
I'm totally lost.
So I should start from the beginning.
I can't even see the screen well because it's just showing me something else here, and then where you're presenting something is just small. So I find it hard to see the screen well.
The screen, we look at the screen. Can you see what's on the board? The board is where I'm writing. The screen is just the question. Can you see the board at all?
Yes, I can see the board, sir.
Good. So the screen is just for the screen you can touch your screen so that it can be bold. You can put it in what is it called, landscape, so you can see the question. But for the board, if you are looking at the board, but you understand how this electrolyte dissociates, right?
Yes, sir.
Good. Now I say that when an electrolyte dissociates, when an electrolyte like sodium chloride is an electrolyte, if sodium chloride is dissolved in water, it dissociates into sodium ion and what? Chloride or ion. Initially, the total particles there, as in 100%, you cannot say exactly the amount of particles. We say just 100%, meaning it's complete. Is that clear? Meaning complete, 100%. Now, but if it dissociates 90%, that means it will yield 90% sodium chloride and yield 90% chloride, sodium ion, and yield 90% chloride ion. Even if this is a trivalent ion, if this would dissociate between 3 ions, it will also yield another 90% of another ion. But this is a two ion. So it's turned into 90% sodium and 90% chloride. The one, this is there, 10% particles will remain here. Then after dissociation, the total particle will increase. Particle there will now become 10% plus 90% plus 90%, maybe 190%. That means it has increased above the 100% that was there before. I factor is the particle, is the ratio of the particles after the dissociation over the particles before dissociation. Now, after dissociation, we have 190%. Before we have 100%. That's why we got 1.9 for an electrolyte like sodium that dissociate 90%. But a non-electrolyte like boric acid does not dissociate. So everything before is 100%, after is 100%. I factor for such solutes is 100 over 100, which is 1. So not all solutes are electrolytes. Some solutes are non-electrolyte, like boric acid. I don't know. Damian, is it clear now?
Yes, sir.
Good. Now, having calculated this I factor, we will now move back to the question and now solve the main thing. Now, this is time to solve the main question. The question says, it says, sodium chloride is a 2-ion electrolyte, CET, dissociating 90%, which we have done, in a certain concentration. Calculate the freezing point of a molar solution of sodium chloride. Calculate the what? The freezing point of a molar solution of what? Sodium chloride. Now, to solve this question, we have a formula. First of all, you ask yourself, what is a molar solution? What is a molar solution? Excuse me, I'm coming, please. Sorry. Hello, are we there? Sorry. Where did I stop? Okay, I was trying to explain something. I was trying to explain, calculate the freezing point of a molar solution. For you to understand the molar solution, we must understand the term molality. Please, molality is not the same thing with your morality. Sorry, molarity in your chemistry. Molarity is different from molality. There are two different things. This one, the first one you know in your secondary school is molarity. This one is molality. LL. Molality. This one is molality. What's going on? Please give me a marker from that cupboard, please. Huh? Okay. Molality and molarity are not the same thing. Molarity, molality. So the one we are talking about now is molarity is your normal molar concentration, you know. So our focus is on molality. In molality is simply talk about the ratio of the mole, mass of 1 mole of a substance to over 1 kilogram solvent or simply water. Mass of 1 mole or simply molar mass of 1 mole. Mass of 1 mole over 1 kilogram of the what? Solvent. Now, for sodium chloride now, the molarity talks about mass of 1 mole. Sodium chloride is NaCl. Sodium is
23.
20 what?
23.
Chlorine is what?
35.5.
Making it 58.5, right?
Yes, sir.
So it becomes mass of 1 mole is simply 58.5 grams over 1 kilogram of solvent. That's what molality is all about. Now, in these freezing points, depression, the molality of different substances depress 1 mole, a molar solution, that is a molar solution of substances, of solutes, different substances. Each of them, their molar solution depresses the freezing point of water by 1.86 degrees Celsius. A molar, different substances cannot have the same molar. 1 molar solution is not the same concentration because their molar mass differ. Hope you know. Sodium chloride, boric acid, they will not have the same molality, as in their molar solution will not have, it's not the same amount. It's not the same thing because they have different molar masses. Now, but in all, a molar solution of solutes, any solute, depresses the freezing point of water by 1.86. That means a molar solution have freezing point of minus 1.86. Please note the difference between depressing the freezing point by, and that the freezing point is. Let's assume that the substance has that the freezing point of water, ordinary solvent, is 0 degrees Celsius, and you add it boric acid, it depresses by, let's assume you add a molar solution of sodium chloride, it depresses by 1.86. That means here by 1.86. Remember that anything below 0 is minus. If it depresses by 1.86, from here to here is by 1.86 degrees Celsius. Why the here is minus 1.86? So if you hear by, we bear a positive, it's magnitude. It's asking you the magnitude of the depression by 1.86. But if you hear, but this is the solution that was formed. This is the freezing point of the new solution formed. The freezing point is minus 1.86. But by virtue of adding that electrolyte, it depresses it by 1.86, which is magnitude. Magnitude and no sign. Simply leave it like that. But if you're talking about the actual freezing point of that new solution formed, is minus 1.86. Now, going to the question, say calculate the freezing point. The question didn't ask you calculate by how far it depressed. No, it asks you to calculate the freezing point. So this is the point it wanted to calculate. Now, for non-electrolytes like boric acid, the freezing point, the depression is simply this 1.86 I mentioned is what is called cryoscopic constant. Cryoscopic constant. Cryoscopic constants is 1.86. Now, for all these solutions, the freezing point depression formula is cryoscopic constant, which is 1.86 degrees Celsius, times the I factor of that particular substance solute. So this is the formula for freezing point depression. Is freezing depression is equal to cryoscopic constant times the I factor. Now let's assume that the substance in question is boric acid. Boric acid I factor there is 1. So cryoscopic constant, so this freezing point depression is 1.86 times minus 1.86 times I. This is minus times I factor. Now, but this is not the same thing for sodium chloride. We are going to calculate the I factor for sodium chloride as what? 1.9 based on the question. Who is there? Okay. Based on the question. So if we calculated the I factor of sodium to 1.9, that means the freezing point of a molar solution of sodium chloride that dissociates 90% will give you minus 1.86 times 1.9. What is the answer?
Minus 3.534. That's B.
Minus 3.5 what? 3.
Yeah, 3.
Which one is the option? Okay, we stop at this level. 3.53 degrees Celsius. This is the freezing point of this solution of sodium chloride that depresses 90%. Had it been, had it been dissociate with another maybe 80%, this will change. Because do you know why? Dissociation yield more concentration. So as the concentration changes, the freezing point will change. Freezing point will change because freezing point changing depends on the concentration of the particles in that solution. Now, This question can be twisted as follows. They can twist the question by asking you, instead of asking you the freezing point, they'll ask you a molar solution of blah 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 that dissociate 90% will depress the freezing point of water by dash. And even they ask you will depress the freezing point of water by so amount. What are you going to say? What should be the answer?
It should be I think 1.9 or something.
Just remove this sign. This minus 3.53 is actually the freezing point of this solution of sodium chloride in water that dissociate 90%. If they ask you, initially before you add that sodium chloride into ordinary water, if they ask you by how far will it depress it, that means you will depress it by 3.53, not by minus 3.53 degrees Celsius. Is it clear, or do I explain more?
Please explain more, sir. Don't be offended. Explain more on this last side.
I will not be offended. Let me explain. Even though my battery light is up, we are having issues with light here. My battery is 16%, but I will explain. Just listen. Where the issue lies now is on the by and the freezing point, right?
Yes, sir.
Now let me explain. But you understood up to this level.
Yes.
Good. Since you understood up to this thing is actually the freezing point of that solution formed. That solution of sodium chloride. This is the freezing point. Remember, I said that freezing point of normal water is 0. If you add sodium chloride, it will decrease to minus 3.53. That's the meaning. Do you understand?
Yes, sir.
Now, so if water normally has freezing point of 0, you now add sodium chloride, the freezing point of the new solution will be minus 3.53. By how far did that sodium chloride you added depress the freezing point of water? By how far?
I think it's by 3.53.
By 3.53, yes. Normally, before sodium chloride appeared in the picture, normal water has freezing point of 0 degrees Celsius. And you now add sodium chloride. The freezing point will depress, it will go down. It cannot give you that 0. In fact, that's why they use it to detect purity of water. Are you aware? Purity of liquid, are you aware?
We are just finding out.
Purity of liquid. Huh? You say what?
You asked whether we are aware. I said we are just finding out.
Good. It's okay. It's okay. They use it to check the purity of substances. If you have if you have water and you're looking at the water, are you aware that water can contain some substances that is even tasteless? Are you aware?
Yes, sir.
That ordinary water will freeze at 0 degrees Celsius. But if that water contains something you don't even know, if you check the freezing point, it will not give you 0 degrees Celsius. It will give you minus something.
Yes, sir.
It means that the freezing point of water has been depressed by that thing you added. Added it, sodium chloride, and it formed the solution. The point of water was depressed by 3.53 degrees Celsius. But the freezing point of the solution formed is minus 3.53 because it's less than 0. Don't worry. See what will happen, eh? Can you hear me?
I can hear you, sir.
Yes, sir.
Yes. The most important is that you guys understood how we got this minus 3.53.
Yes.
I'm sorry, I don't know what to do. power. This thing is we're having power issue here. So any small like child that try to utilize it. So what will happen is this, I will end this for now. Then if we convert again tomorrow, I will try to explain this. That I know where the issue lies now. This depression and the freezing point. That's where the issue lies. Okay.
Okay, sir.
I'll try to put more light on that. Is that clear?
Okay.
Okay, sir.
Is that clear?
Yes, sir.
But at least now you understand the formula for freezing points. Right?
Yes, sir. Yes, sir.
186 times what? I factor.
I factor.
Is that clear?
Yes, sir. And sir, please, you said that this 1.86 is constant for all the ions that can be passed.
A
Yes.
molar solution of substances. Solute.
Okay, sir.
Yes. No, well, in the next class we'll talk more on that.
Okay, sir.
Where the issue lies is on this science.
No, wow. Yung ka boca rice. Yung ka boca rice. Isi actually money.
I will give you 100 naira. Where are the sick? Where are the sick? Come on. Are the sick back? Where are the sick? These are this. Huh? I will punch you. Huh? You want? Come on. I mean, the blood like that.